I'm Erin, and today we're going to be talking about graphical displays of univariate data. Univariate data. Well, what the heck is univariate data? Well, you can take a look at the word univariate for a clue. It sounds like a $10 word, but uni, we think of unicycle. Unicycle has one wheel, so univariate data is just looking at one aspect. It's just measuring one thing. So, for example, a lot of times when someone is creating a survey or doing some observational study, they might measure one variable at a time. Let's imagine that we have a teacher who's interested in her students' sleeping patterns. So she does a survey, a questionnaire to find out how many hours of sleep the students got the night before the midterm, rounded to the nearest hour. And this is the data she gets. So we've got 3 hours, 6 hours, 6 hours, 7 hours. We've got this for 12 different students. Well, that's all fine and dandy. We got the data that the teacher was interested in, but it's just kind of like a messy list of numbers here. We can't easily, just at quick glance, make any conclusions about the data, find any patterns, figure out what the general trend is. That's going to take a bit more time to, reorganize the numbers, maybe do some more calculations. So really, to make the biggest impact when communicating the results of your data, and also to try to start finding patterns yourself as a researcher, you want to start making visualizations so that you can see these trends yourself. So there are a few different graphical displays that we use for univariate data, and I'll list them out here. So common graphs we use would be, dot plots. We might see some histograms. We might see a box. Well, I'll do say stem and leaf plot. And lastly, the fancy box and whiskers plot. And no, that sadly does not involve a cat. All right, so we've got 4 awesome graphs here. We can't go over all 4 of them in one go, so we'll see the others later. We're going to start here with dot plots to begin with. So we're going to say goodbye for now to histograms, stem leaf plots, and box and whisker plots. Let's figure out how to make a dot plot of the data we have here above. All right, so it's pretty straightforward. We're going to start off by creating a horizontal axis. So let's make our horizontal axis here. And we're going to make some simple intervals and label our axis here so that any reader can understand what they're looking at. We see that our smallest value here is 3, our largest is 9. So let's make some hash marks here to actually label our intervals. Let's see, 3, 4, 5, 6, 7, 8, 9. And now I'm actually going to label my hash marks. 5, 6, 7, 8, and 9. Well, if you're just joining us now, what is this? 3 puppies, 7 crocodiles. We actually have to label what these numbers mean. So this is the number of hours of sleep. The night before, I'm just going to say before the midterm. All right. So it's pretty straightforward here. To create this dot plot, to finalize the dot plot, we actually have to make the dots. And that's going to involve putting dots above the appropriate value on the x-axis. So we see here that we've got 1, 3, so I just need to make a single 3 above, or dot above the 3. No 4s. We do see we have a 5, so let's put a dot above the 5. Okay, 6s, we definitely got 6s. We've got 1, 2, 3 6s, so I'm going to make 3 dots there. Now we're up to 7. We got 1, 2, 3, 4 dots to make above the 7. 1, 2, 3, 4. I've got 1, 2, 8, so those 2 dots there, and then 1, 9, so 1 dot above the 9. Now, immediately, this is a much more attractive way to present the results of our survey. And on top of that, well, we can kind of see some patterns. Right now, we see that the majority of students have between 5 and 9 hours of sleep the night before the midterm, right? So that's where the majority of our dots are. This lonely little 3 here on the left is an outlier. It doesn't really fit the trends of the class overall. On top of it, we can pull out some data or statistics that we've talked about in another lesson. Well, do you guys remember that term called mode? This is the value in our set that occurs the most, and immediately we see that, well, 7's got the most dots there, so the mode for our set of data is 7. And we didn't have to go through and count the 7's up here. We just quickly see that it's got the tallest column of dots. We can also, on top of that, start to make some conclusions about the mean and median as well. We'll talk about that in a few minutes. Now, once again, dot plots are great to see the general spread of the data, find some where the majority of our data points are concentrated, visually easily identify which points look like outliers that might pull our data in one direction or the other. But what if this teacher instead decided to do the survey for her entire school? And let's pretend that there were 600 students in her school. Well, I mean, that certainly the more data we have, as long as it's, representative of the population, the more data, the better, the more thorough it's going to be. We'll probably see more patterns emerge from the results of that survey. However, if we have 600 dots here, imagine that. We're going to have like dots going pretty much all the way up past our paper, right? That's a huge number of students. So as soon as we start to have a lot of data points, it starts to become kind of unreasonable to figure out, well, the actual frequency of the different values. I'm not going to sit here and count hundreds of data points above, the 6 or above the 7. That's not very an efficient use of our time. So yes, the dot plot has some great advantages. However, it does have some disadvantages as well. So if we want to start really diving into calculating our measures of spread, talking about mean, if we go into standard deviation, things like that, then other diagrams such as histograms are going to be more useful for us. So lovely dot plots, pretty easy to come up with, but we want to have other tools in our box as well. So let's next look at histograms.